Okay, in this tutorial I'm going to show you one problem, and it's about how to find the derivative using the definition of the derivative. So take a look at this this prompt. It says to find the derivative of f of x equals x cubed plus 2x. Now, before we get going, I'm going to tell you that this is going to take up quite a bit of space, so I will make sure that I keep everything really nice and organized for you, but also that if I happen to erase everything, that you can remember to do that, you can pause it and look back. So the first thing that I want to make sure that I do is write down the definition of the derivative, since that's what it's telling me that I have to use. Alright, so here's the definition, and if you've read all of the tutorials, you should know that the way that you say this very first part is f prime of x. Okay, that's how you know that it's the derivative, and it is equal to the limit as the change of x approaches 0 of this terminology. So, the part that we started with, my function part, x cubed plus 2x, what am I supposed to do with this? What does this definition tell me that I'm actually doing? When I take a look at the very first part, right here in green, if this x plus delta x were a number, pretend it said f of 1, what would you do? Well, if it were me, I would simply plug 1 into everywhere where I see an x. So this x would become 1, and this x would become 1. The idea behind this is no different, it's just a little messier. So to get this first part taken care of, I am going to first of all rewrite my limit notation. Change of x approaches 0. So I'm going to plug this x plus delta x in for x of that entire part. So I'm going to rewrite the x parts in green. So this is what I'm substituting the very first x with, x cubed. So it's going to read x plus delta x, and then I'm going to cube it. Okay, and then I'm going to write plus 2, and then I'm going to replace that with x plus delta x again. So that has taken care of the first part up here. Now I'm going to subtract f of x. And what's nice about this is that's just me replacing x with x. So nothing has changed. So that just means it is x cubed plus 2x. And then in the denominator, it's just going to be delta x. Alright, so now the next part is to just simplify. We've taken care of the hardest part. So let's go ahead and once again rewrite all of our notation. And what we need to do now is that x plus delta x business we are going to cube out. So that we can work on a separate occasion. If you want to ask me how to do that in class, that's fine. But after you're done cubing it, I'm just going to write out what you should be getting. Okay, and I'm going to keep it in green so you know where it came from. So I should have x cubed plus 3x squared delta x plus 3x times delta x squared plus delta x cubed plus, and now that takes care of this cubed part. Now we're just taking a look at the 2 times x plus delta x. When I distribute the 2, I just get 2x plus 2 delta x. And I'm going to do dot, dot, dot because I can't fit it in, but all of this goes right here. And then this is all over delta x. Now, I know that this looks really, really messy, and that's because it is. And that's why there's shortcuts to this, which we're going to see very, very shortly. But you still have to understand where all this comes from. So what I am going to do here is I'm going to rewrite this so that everything is on one line, because I didn't know that I was going to run out of room, so that it's a lot easier for you to see. So in about 2 seconds, this is going to completely change. Okay, so I rewrote it. Now, the only thing that I left out was the part that we were going to write down, and because I want to make sure to reiterate to you that this negative sign right here is being distributed. Okay, so that changes the sign of both of those terms, so it's minus x cubed and then minus 2x. So be really, really careful when you get to that step. Okay, so where do I go from here? Now it's just a matter of simplifying. So I'm going to rewrite my limit notation, and you have to keep that with you at all times. And let's see if there's anything that we can cancel or reduce up here. Now I do see that there's a positive 2x and a negative 2x, so those are going to cancel each other out. I also know that I have an x cubed and a negative x cubed, so those are going to cancel each other out as well. Now, what I do see is within every single term, I see delta x, delta x, delta x, delta x, and delta x. And remember that at this point in time, you should be aware that you cannot take out or simplify these terms with factoring unless that term is present everywhere, especially when there's plus and minus signs all over the place. So let's go ahead and rewrite this. Now this delta x is going to cancel all the way out because I'm taking 1 out of all of these terms. So that's just going to leave me with 3x squared. And then here, the next term, that's no longer just going to be 1, that's going to be, sorry, that's not going to be 2 anymore, I'm just going to have 1 delta x. So plus 3x times delta x. And this next part, this delta x cubed, is no longer going to be delta x cubed, it's going to be delta x squared. And then down here at the end, this delta x is going to go all the way away, so plus 2. And then the denominator, that's just going to be a 1 since it's going to be canceled out. All right, so where can I go from here? Well, since there's no other simplifying for me to do, I'm going to go ahead and see if I can go ahead and substitute that 0 in for all of my delta x's. And I forgot to write x there. Okay, so let's go ahead and do that. So this first part is just going to give me 3x squared. Remember, I'm not replacing x with 0, I'm replacing delta x with 0. Now this term, because delta x is 0, this whole thing is going to go away. It's not even there anymore. The same thing here. When I square 0, it's just 0, so that's gone as well. And then at the end, I have plus 2. And this is my answer. This is f prime. So I'm going to write f prime of x equals 3x squared plus 2. And this is my final answer because remember that the derivative just isn't a number, it's a function. So this f prime of x equals 3x squared plus 2 models what the slope looks like as the change of x approaches 0 on my original function, x cubed plus 2x. And if that's confusing to you at this point in time, it's okay. We're going to see how this works later on, but know how to get from this first step all the way to the bottom. Worry about that part for now, and then we'll see what to do later. That concludes this tutorial.